Okay, so this is my presentation on the quantity theory of money, inflation, and interest rates. So let's use an equation to try and help us understand this a bit better. We have m times v is equal to p times y. So m is denoted as the money supply, v is the velocity of money, p is the price level, y is real GDP, and if you actually multiply p and y together, that can be simplified as the nominal GDP. So what do all those things mean? Well, the money supply is the total amount of money in circulation in a certain country. The velocity of money is the average number of times that $1 in the money supply is used to buy finished goods or services in a given year. The price level is the price of all goods and services in the current year. Real GDP is the value of all final goods and services produced in a given country calculated using base year prices. And nominal GDP is the value of all final goods and services calculated using current year prices. Now that helps us to understand the quantity theory of money a little bit better. So this is a theory about the connection between prices and money that assumes that the velocity of money is constant, which was developed by an economist named Irving Fisher. Now Fisher argued that it takes a long time for the velocity of money to change, like requiring people to get paid or going grocery shopping or paying for bills, because we actually need this money to change hands and start circulating. Which is why for the purpose of this equation we will assume that the velocity of money is constant. Now let's try and see how this relates to inflation. So in order to do that, we need to use a mathematical rule that states if there is an equation where variables are multiplied together and it is equivalent to an equation where the percentage changes in variables are added together, then we can actually just rewrite the equation. So we go from m times v equaling p times y. We can just rewrite that as the percent change in m plus percent change in v equals the percent change in p plus the percent change in y. Now, since Fisher assumes that the velocity of money is constant, we can just say that the percent change in v is equal to 0. We can also redefine the percent change in price as inflation, because that's just what inflation is. It's the change of the price. And since we can now substitute the price level for inflation, as well as remove the velocity of money, because we are assuming it's 0, our new equation looks like this. We have inflation is equal to the percent change in m minus the percent change in y. Now, the important thing to take away from this equation is that if the money supply, which is the percent change in m, is growing quicker than the real GDP, which is the percent change in y, then we're actually going to experience inflation. Now, how does that connect to nominal interest rates? Well, let's define the expected real interest rate, which is the real interest rate that borrowers and lenders expect at a time that a loan is made. Now we have the expected real interest rate on a loan will equal the nominal interest rate minus the expected inflation rate. And from that we can get this equation where we have the expected real interest rate equaling the nominal interest rate minus the expected inflation rate. And the important thing to draw from this is that if actual inflation ends up being greater than the expected rate of inflation, then the actual real interest rate will end up being less than the expected interest rate. This means that people who borrow money will end up better off, and people who lend out money will end up being worse off. Now let's talk about the Fisher effect. So this was an assertion by Irving Fisher that the nominal interest rate will either rise or fall by the exact same amount that the expected inflation rate will rise or fall by as well. Then we have the Fisher equation, which is the nominal interest rate equaling the expected interest rate plus the expected inflation rate. Now the important thing to take away from this is that if the money supply grows quickly, it will cause inflation to increase. Then that will also cause the nominal interest rate to increase. Now let's look at some questions. So if the money supply of Uruguay is $10 billion, the real GDP is $120 billion, and the price level is 1.2, then what is the velocity of money for Uruguay? So all we need to do is pull our quantity theory of money equation, and then we just need to substitute some values in and rearrange for the velocity of money. So we will simply divide by m, then we will get m on the other side, and then we just need to substitute our values in. We will put in 120 billion for real GDP, 1.2 for the price level, and 10 billion for the money supply, and we will solve, and the velocity of money for Uruguay will be $14.4 billion. Then let's say that Japan has a real GDP growing at 15% and an inflation rate of 8%. Japan is also issuing government bonds that have a nominal interest rate of 13%. What is the money supply of Japan growing at, and what is the real interest rate of the government issued bonds? So this is a two-part question, so we're probably going to need to pull down two different equations. So in order to figure out what the money supply of Japan is growing at, we need to use the inflation rate equation. So we can see that inflation is equal to the percent change in m minus the percent change in y, and we have inflation and real GDP, so we're trying to figure out money supply, so all we need to do is make the left and right side equal to each other, and we can figure out the money supply of Japan is 23%, And then for the real interest rate, we need to use the real interest rate equation. So we can see that we have nominal interest rate of 13 and we have inflation rate of 8%. So in order to solve that, we just need to make the left and right side equal to each other. And then we can solve that the real interest rate of the government issued bonds are 5%. And then for my works cited page, all the definitions and information I found was found from our textbook, the Macroeconomics Herbert O'Brien, Rafferty, and Kaninsky Canadian edition.